I'm a science educator, and what I'm particularly interested in, and I'll be talking about in this talk, is how can we help students to understand powerful explanatory ideas in science. And as a science educator, I of course have to have my hands-on prop. And so this is a syringe that you can use for orally dispensing medicine. And I've just, I don't know if you can see, but I've sort of melted the tip so that the tip is completely blocked off. And so, and then the plunger, so what happens if I push the plunger in? There's obviously no way for the air to escape. What we find is that when I push the plunger in, I'm able to push it in. I'm pushing as hard as I can. I can't push it all the way in, and then when I let go, it pops back out again. And so those are observations that we want students to try to explain. And of course, they have various ways of explaining it. And one of the things that we're using is a simulation, which I'll show here. And this is a screenshot of a dynamic simulation, so all of those little balls are bouncing around. Those are meant to represent air molecules. And this right here is meant to represent the plunger. And as you move the plunger in, you can see that the air molecules get more squished together, and they also hit the plunger more often. So that is a measure of how often they hit the plunger is a measure of the pressure, and as it goes in further and further, the pressure goes up and up. And here the molecules are really hitting the plunger very frequently, which is the kinetic molecular explanation for why it gets harder and harder to push as you push the plunger in. And so we want to help students develop this kind of understanding, this ability to develop an explanatory model that uses unseen elements, in this case molecules, to explain observable phenomena. And here is another title that I could have had for the talk, talking about the two projects that are sort of hopefully working together, one of which, the ASSIST project, which is a proposed project, and then the GRASP project, which has just started. And so the ASSIST project, how can we help students work through these simulations in ways that are optimally beneficial for each of the students? Now, this is an open question, obviously, and it's a very difficult question. There's, of course, been a lot of work on adaptive systems. Often they're in contexts that are very constrained. This is a much more free-form, ill-defined, human intuitive domain, so it's a very difficult problem. And so we'll be working a lot with individual students and trying to see how do sensitive human tutors do this, and is there adaptivity that we can take from that and put into an adaptive system. And then also working with gesture recognition, which is getting much more sophisticated and more ubiquitous. And as Robb was talking, who is also working on this project, he's the PI actually of this particular project, the GRASP project. How can we use students' hand motions? In this case, for example, a student who is talking about the molecules hitting the plunger. And so what are students' kind of natural ways of using gesture as they're explaining? And can we incorporate those sort of natural ways of using gesture in ways that will help them to control the simulations using their body motions as opposed to mouse and trackpad? And so just to end, think about two classrooms and that are both using simulations. Let's say they're both using that particular simulation or something like that to learn about gas laws. And in one classroom, they're using linear framing in the form of, say, a worksheet, where every student has a worksheet and they have to, it says, you know, do this to the simulation, observe this, write down your thoughts about this, that sort of thing. In the second classroom, they're working through adaptive framing of the simulation, so that different students, based on their input to the simulation, might be diagramming, as Emma was talking about, which I think is a fabulous idea. It could be other kinds of things that the system is able to sense that, well, this particular new thing would be helpful for this student, whereas something different might be helpful for a different student. And then also in this other class, the first classroom is using traditional mouse trackpad control for the simulation, and the second classroom is using conceptually congruent gestures, such as, you know, the molecules hitting the piston or something like that, that can help to get students even more immersed into the simulation.